Okay, everybody, welcome to this webinar where Mimaki and Trotec are joining forces. I see still a lot of people are coming in, but anyhow, we like to start. We are recording this webinar, so everybody who registered will have a link to listen back in case if they are coming in late. So first, let me show you the agenda for today. So we will start in a moment with my colleague from Trotec, Michael Gastenauer. He will introduce the Trotec company. He will talk about laser cutting and endless possibilities to print and cut, where we're combining our both brands together. Then it will be my turn with Mimaki, the company introduction. I will focus mainly about the LED UV printing machines that we have. I will show some workflow solutions that we are working on at this moment. And then we will finish with a movie, which we shot here in the showroom, where we see the workflow, how to prepare and how to print and how to cut objects with both our printers and laser cutter. And then we will end with a Q&A session. So hopefully we can make it within 45 minutes. We will do our best. We prepared some nice slides for you all. And let's start with some housekeeping rules. So basically, everybody of all the ones that are registered are muted. And like I said, this session will be recorded, so you can listen it back. And if there are any questions, then you should have a tool in your screen with a chat functionality, and there you can launch your questions. And during the Q&A session, we will pick out a few questions. And at the end of the webinar, both Michael and I will answer all the remaining questions that we were not able to answer during this webinar. So let me introduce Michael Gastenauer, my colleague from Trotec, Austria, a company that is already for a long time in laser cutting, laser marking. So Michael, please take over, and I'm very curious what you are about to say.
Thank you, Bert. Welcome everyone to this session from my side as well. My name is Michael Gastenauer. I'm product manager for cutting systems at Trotec Laser. I will take over the presentation now. So, who is Trotec? Maybe a short introduction for the people who don't know yet. We are based in Machtrenk in Austria. Have about 750 employees around the globe. We are close to our customers with 17 subsidiaries in the countries and are active in 104 countries overall, the remaining countries through dealerships. We have one motto that drives us. We want to make first-class laser system solutions and materials to make our customers more profitable. So it's your profitability that is in our focus, and all our actions drive us in this direction. Regarding laser systems, we have three basic series. One is called the Speedy series. These are flatbed engraving and cutting machines, ranging from A3 size to 600 by 1000 millimeters. Mainly engraving, but they do cutting very well for smaller objects. Then there's the SP series that extends the size range of materials from 120 centimeters by 70 centimeters up to 2 by 3 meters. Mainly cutting, some engraving. And there's the Speed Marker series, a galvo system for marking of objects. In this presentation, we will focus on the Speedy and SP series that work well in a print and cut workflow. I've also added some indication of price range. This price range depends a lot on sizes, on laser power, and on actual machine options. And the best way to get the real price information is to get the quote for a dedicated system. What is laser cutting and how does this work? I want to give you a short introduction. It all begins with a laser source. This laser source generates a laser beam. We typically use infrared light, so the laser beam is not visible for the applications that we have in mind right now. The power range is about 30 to 400 watts, so we have a wide range of available power, depending on your material thickness and your productivity needs. The beam path is a set of mirrors and lenses that delivers the laser beam to the cutting head. Then there's a motion system that moves the cutting head across the workpiece in X, Y, and Z direction. Then there's, of course, a lens that focuses the laser beam on the workpiece surface to make sure that you get really high energy density there. And at the workpiece, the laser beam energy lets the material sublimate. What does sublimate mean? It changes from the solid state immediately to gas state. So it's not melting, but it's immediately converted into gas. What are the properties of laser cutting? It creates a very thin curve. So the cutting gap is, the tool is very thin, in the order of 0.1 to 0.2 millimeters. It's contact free, so there's no force on the workpiece, and it directly converts from solid to gas. So if you extract the gas, you have a very clean process. There are some key success factors for laser operation. First of all, the machines have to be safe. This should be obvious, but the restrictions and the guidance from both the EU and insurance companies is getting stricter and stricter there to make sure that both the machines are safe and that the exhaust gas is treated properly. And this makes a big difference between laser machine manufacturers, and we take a lot of care to make safe and clean machines there. The process technology, every process, every material needs its correct parameters. You have a few parameters like power, speed, or the addition of process gas, where you can influence the desired results. And you can always do a trade-off between the throughput and quality, depending on your actual needs for a certain workpiece. The exhaust system is a key feature in a laser system. It's underestimated in many times, but it's of high importance to have a reliable operation, and you have to make sure to have a good exhaust system in place. Actually, we do offer exhaust systems that complement all of our laser machines. And last but not least, it's important to have a simple workflow to handle workflows easily, to follow through the steps of a workflow easily. And I think the Mimaki Trotec integration is a excellent example of such an integration. You will see this later in this presentation, in this video, how this is integrated. So with all that said, what are the benefits of laser cutting? Basically, it allows you to have more freedom in your designs and gives you more possibilities to design products. You start with your well-known possibilities of digital printing. You have graphics, colors, and lots of possibilities regarding your artwork. Laser cutting, laser finishing adds the degree of freedom of shape, which means that you get out of your rectangle and have arbitrary shapes, and you can use structure, meaning that you can combine things, you can have different work materials, and you can structure your object, your workpiece in a more flexible way. I'll address the two additional parameters right now. What does adding shapes mean? It lets you break out of rectangles and squares. The creativity is regarding shapes is endless, and you can really create exceptional designs. The integration of graphics and shape together gives you just so much more possibilities to tell the story and to provide convincing products. And it's fully digital, so you, as printing is, so you can both create the print and shapes in a completely personalized way. Adding structure, what do we mean by this? You can combine parts, meaning that you can leave the plane as your limiting factor, and as shown in the picture below, add different printed and non-printed parts to a combined workpiece. You can combine materials, as shown on the right side. We have a printed MDF sign, and there's an inlay out of acrylic, and this is all packaged in some laser cut foam. And you can add these highlights to your design. It makes your design stand out of the usual. And there's an additional process that you have at hand, which is engraving. For example, on this right side, the Trotec logo inside the foam was engraved, as printing is quite difficult on foam. So what are the advantages of laser compared to other cutting or finishing technologies? If you have acrylic workpieces, you get polished edges right out of the cutting process. This saves time and risk. You do not have to polish anything afterward in some risky and time-consuming process. It's a clean process, so there's no dust and debris. Your printed surfaces are not damaged by scratches, and you can quickly turn over from job to job because you don't have to clean the machine in a painstakingly way. You can create very fine details, very sharp corners, small structures. We have this tree example here shown, so very, very delicate structures are possible, and the shapes are not limited by your production technology. And the fourth advantage, it is gentle to your print. If you cut printed objects, there's no stress on the print, there's no vibration of the workpiece because it's contactless, and so your print remains clean and is not destroyed. The question of materials, is it universally applicable? It's applicable for a wide range of material. Acrylics is a very prominent material for print and cut applications. Other plastic materials such as ABS, polyethylene, polypropylene, twin wall or hexagon graphic sheet for signage applications, all kinds of foil materials, self-adhesive, are well suited. Wood-based material such as MDF, plywood, veneer, or solid wood, as we will see in our example later on. Wood fiber-based graphics boards, something that's very eco-friendly, recyclable, and hard to process with other cutting technologies. There are different brands out there. They give excellent results with laser cutting. Paper and synthetic paper is also an option, and synthetic textiles and non-PVC banner materials. Speaking of non-PVC, excluded materials are PVC-based materials because they create poisonous fumes. Unfortunately, that's not possible to cut with a laser. And metal plastic composites such as debond, they cause headache as well. So which product from Mimaki and Trotec would you combine? The first combination that we would like to highlight is the Mimaki UJF 7151 Plus with the Trotec Speedy 360. This is also demonstrated in the video afterwards. It gives you the possibility to work on workpieces up to 50 by 70 centimeters. Typical target applications are gifts and novelties, small signs and displays, awards and trophies. Sample images are shown below. They give you, this is really a nice combination. You will see it in action later in the video. If you need larger workpieces up to 250 by 130 centimeter, you can use the Mimaki JFX 200 2513 together with the Trotec SP 2000. The workpiece size is then 250 by 130 centimeters. Typical applications are indoor, outdoor signs and displays to attractive sizes already. And I would like to hand over back to Bert, and we'll meet at the Q&A session afterwards.
Thank you, Michael, for this interesting story. Let me continue with my part for Mimaki. So also, I want to mention and start with our company overview. So Mimaki Engineering is a Japanese company and was founded in August 1975. We are close to Nagano in Japan, and currently we have just over 1,600 employees working on all those printers in the market. So we are a global company, so we have offices all around the world, covering most of all the countries, as you can see nowadays. And for now, we are, let's say, speaking on behalf of Mimaki Europe. So Mimaki Europe is covering the EMEA region, so Europe, Middle East, and Africa. Also, we have some offices in this region, supporting 100 countries in EMEA. We work with a partners network. We have distributors and local dealers, basically in almost every country of EMEA. And to give you an example, we have over 55,000 Mimaki units up and running. So what about our business unit? So basically we have 4. So the first one, and this is also the one Mimaki started in, is this SG, Sign Graphics unit. So everybody probably knows about that, recognizes Mimaki in this sector. So this is for the people that are doing car wraps, soft signage, display panels, this kind of all advertising. Then the other one is industrial products. So this is more to the UV printing systems. The next one is textile. Also, Mimaki was the first to introduce digital printing with textile inks in the market. And the last one is factory automation. Basically, for this webinar, I want to focus on the industrial products with the flatbed printers and workflow where this connects with factory automation. So let's have a look at our printers first, our lineup. So first of all, I want to show you the roll-to-roll. So this is all LED UV printing. We have different sizes, different possibilities. We have cutting integrated or just printing without cutting, where you combine, of course, with Trotec. The price range here is just below 15 up to just below 25,000, depending on the size and the speed. Each and every machine also has its different options. The next one is the LED UV flatbed, the small lineup. So basically, we have our UJF 3042, where 3042 stands for the table size. so 30 centimeters by 42. Then we have the following up from the FX, which is much faster. It's the MK2 version, and even the EX model, where we added an extra head for more productivity. Then we have an A3 size model, the 6042 with 60 by 42 centimeters. And the last one, as Michael also showed, the 7051 Plus. This is our most industrial product in this price range, with the highest quality and productivity in the market today, even with a silver metallic ink as only one in the market. So also price range, when I need to mention that one, it's just below 15 to start with the FX, up to just below 43,000 for the 7051 Plus. The last one is, let's say, the large flatbed lineup. So we have 4 models. We, as Mimaki, were the first to introduce LED UV light in flatbed printing, and we started with the JFX series. And now, when you look at the lineup from left to right, we have the 2513EX, our JFX 200 model. It's the latest model. Then we have the JFX 200, 2513, where 2 meter 50 by 130 is then again the size. We have the 2531, so it's with an extended table, where you can do your production like a ping pong table. First the first half, then you switch and prepare the next part of the table. So that is 2 meter 50 by 3 meter 10. And the last one is our JFX 500, 210 by 310. When we look at the price range here, it is just below 55 up to 100,000 euro. Nowadays, with this whole situation and this virtual weeks that we are organizing already for the 5th week in a row, I believe it is, we have some special pricing for you for basically all our printers. So if you are interested, please check out our website or contact your local Mimaki dealer. So at the end, I want to come to the conclusion that with LED UV printing, basically we can print on anything. When it's flat and it's rigid, we can basically print on it. All the examples that Michael showed you what to cut, also we can print on. So if you look around, and this is an example of a house, you see so many products that can be or are printed with LED UV technology. So from a dashboard, from your car, to cornflakes in this case, packaging, textile even, so we can print textile, and also Trotec has textile cutting machine. You see the table where we have wooden printing, circuit board. So all around you, you see examples what can be printed with LED UV. So just to give you a few examples in the markets that we are, let's say, selling our machines. You see here, which connects very closely to Trotec, for example, the engravers. Basically, they know already for a long time laser technology, but also our printing machines are well known in that market, and it's combining perfectly both technologies together. Of course, we are very big in the industrial market. Like I said, if you can print almost anything, also industrial applications are, let's say, using this technology. Backlit graphics, outdoor graphics, screen printers, so the whole list, and it goes on and on. So if we look at some applications that are mainly used for UV printing, you see here the list where we have close with our sign graphics business unit, the trade show graphics there, the outdoor graphics, and more industrial. You can see, for example, a membrane switch graphics, lenticular. So a lot of applications, endless possibilities, like Michael had in his presentation. So it's a big opportunity to have both of these machines in your company, and it gives you a lot of opportunity to print whatever you want or whatever is passing by. So a little bit back to school. I always say when I start to explain this, I have some few slides to show you how we cure or how we hard the UV inks. So it starts all with the visible spectrum. So UV is, let's say, part of an electronic magnetic radiation field, and the visible spectrum, so the colors that we are seeing by our human eye, are also kind of wavelengths or radiation, and they are in or between 400 nanometer and 700. So next to that, next to the visible spectrum, so basically what we cannot detect by the human eye, you have the infrared, the microwaves, and the radio waves. And at the other side of the spectrum, you have ultraviolet, X-rays, and gamma rays. So to make it a little bit more clear, so in the middle we have the visible light that I was talking about. Then on the right side you have the ultraviolet light. So this is what we are using to cure our inks with our printing technology. On the other side we have the infrared, and this is the light that Láser is using, and Trotec is using infrared technology in their systems. So about workflow solutions, this is becoming more and more important. What are we developing? We are developing a special controller software which is called IP Job Controller, where we are connecting our printers with external devices such as a Trotec machine, robotics, scanners, label printers, etc. So everything, every machine that is in your complete production process can be connected with our software. This is for us a very important development where we are certain of that has a huge future. Everybody is looking now more and more to workflow solutions. So just to explain a little bit how this is going to look like. So I made an example from an e-commerce size, let's say a web shop, and this is already linked with the ERP software from the customer. And then we have Mimaki IP Job Controller, and this is managing, let's say, all the production processes. It makes it more easier, less errors will be there, and it reduces basically labor. So how does it exactly work? So the moment you have a job coming in, it will control, for example, the pre-process. So let's say that could be laser cutting to prepare from acryl your products that needs to be printed. Next, the job will go to rustering, is our RIP. That is, let's say, processing the image for the printer. Then we have the phase where actually the product is being printed. And then it goes to post-processing again. So that can also be laser, it can be a coating, it can be a lamination, whatever it is needed. If it is done by a machine, we can connect that also with our job controller. Then, for example, a transport robot, which will move it from the machine to the next division. Let's say that could be quality control, where you can do a visual control or even use a camera to control the quality that has been printed. If the quality is not high enough, it can go back into the process. If it is okay, you can do the packaging where you have a label printer. It will print the packing slip, and at the end it will be shipped, and most important, it comes back to the ERP system where an invoice can be generated. So this is basically what we are working on and how Mimaki sees the future of workflow processes and combining not only Mimaki machines but also all the other machines around the workflow and around the production process. So that was a little bit my story. I want to show you a movie that we made last week. It is presented by Pim de Vries, who is our application specialist here at Mimaki Europe. And basically you will see the design preparation, so how he's working in Illustrator. Then he is going to use the file in our RIP and start printing. And then after printing, we need to do the preparation for cutting lines and crop marks that can be detected by Trotec Laser machine. And then the cutting will be executed. So I will start this movie and then we will come back to you and start our Q&A session.
Hello, my name is Pim, and today I'm going to show you how to create this world map sample using the Mimaki UGF 7151 Plus and the Trotec Speedy 360 Flex laser cutting machine. At first we're going to measure the material. The width is 60 centimeters and the height is 30 centimeters. For the thickness of the material, it's 5 millimeters. For this we're using the Trotec wood. It's specially made from Trotec, so there's no hard knobs inside, so it's perfect for laser cutting. After you measure the material, you create a new document in Illustrator. You give it the exact same dimensions as you measured before. This is the artboard. First I designed the color layer. That's this one. Then I designed the white layer. So everything you see here is gonna be printed white. On top of the color and white layer, we're printing a clear layer, as you can see here. And cutting layer is the world map with the vision marks. You can see here that the black dots is also be printed in the color layer. When your file is ready, you can save it. Each layer separate. So this is the color layer. Save the white layer. And the clear layer. And as finishing touch, the cut layer. And then the printing files are done and we're going to Rasselink. When in Rasselink, you can open the files we just made, the clear, the color and the white file. Okay, all three are now loaded. So this white layer, we convert it to the valid pixel white. Put in 90%, otherwise it's maybe a bit too thick, the ink. So do it on 90% valid pixel and then create. The color can be deleted. For the clear layer you do the same thing, only then with valid pixel clear. This one is 100%. Do it valid pixel and create. the color layer can be deleted again. In the info screen you can set up the clear to the UV mode to glossy print, otherwise it's a bit matte. Now you have these 3 layers. We're gonna select them all, and through the composition tab we're gonna arrange it. So first we have white at the bottom, color at the middle, and on top we have the clear. In this way it's also going to be printed. Do a composite. And now it's set up as one printing job. Check your printing conditions with the right resolution and right profile. And when that's okay, then you can go to the general print screen. Make sure it's on the 0 point on the table, and then you can execute the job. Rip and print and start. For this application we are using the Mimaki UGF 7151 Plus because the table size is the same size as a Trotec laser cutter. We place the wood on the 0 point of the table. The media thickness was 5 mm, so now we're going to set up in the machine. Go to menu, select head height and set the media to 5 mm. And then select end to go back to the main screen. The height of the table is automatically adjusted to reach the 1.5 mm head gap between the print head and the material. Confirm by pressing remote. When you're finished setting up the print data, press print. So, as you can see, the printing is finished. Now we're gonna laser cut it with the Trotec machine, the Speedy 360 Flex. When you turn on the machine and close the lid, the table will go down to its lowest point. To set the focus of the laser, we're going to use this focus tool. Now you have reached the perfect focus point of the laser on the material. Set the laser above the vision marks so the laser cutter knows where to cut. Okay, when the job is printed, you go back to Illustrator and open the cutting file. Okay, here it is. Select the cutting lines to check if they are all 0.01 point and a full RGB red. The vision marks, the fill should be all black RGB and the line also black RGB with a line of 0.01 point. When that's all correct, just select it and send it to the printer. Print. Make sure the printer Trotec engraver is selected because this is your job control software. Go to setup, go to preferences, and there you can see your media size. Here the material settings, set it to solid wood. Here you can see the solid wood, the 5 mm maple we used. Make sure the red is set to cut and the black is set to register mark, because the red line is cutting line and the black objects are divisions. Okay. And print. Again print, and job control will open automatically. On the right hand you can see your job and drag it into your working area, drag it to the 0 point, and the laser will automatically recognize the black dots, divisions for the camera. The settings were all done in Illustrator. You can see solid wood, 5 mm maple black, The thickness of the material is 5 millimeters, and your laser cutting settings are also at the top. And then press start. When the cutting is finished, you will hear a beep, and then it's safe to open the lid. To prevent small parts falling out of the wood, secure them with a piece of tape. I put some double-sided tape on the back, so then we can hang it on the wall. And this is the end result. Hope you've enjoyed watching and come up with some nice ideas you can make with the Mimaki and the Trotec machines.
Okay, so this was the movie. Thank you, Pim, for making this movie for us. I'm going to ask if Michael can also join me for the Q&A session. So,
of course, I'm here.
Okay. So before we start the Q&A question, let's say we will send you an email. Everybody that registered and were listening, also in this email, you can find a link where you can look back this webinar, which was recorded. Also, you can see the movie again. Probably also that will go to YouTube or to our website as well. So if you have afterwards still questions, please send us an email on webinar@imia.mimaki.com. And let's say enjoy our last week of our virtual print festival. Just visit our site. We have some very nice content, and as I said, some very nice offers indeed. And together with Michael, we are going now to have a look to some questions. I don't know, Michael, you have a view to all the questions as well, like I do?
Yes, I do. I have one question from Cristiano concerning materials for laser cutting. He's asking if polyester, polycarbonate, and PET sheets can be cut with a CO2 laser. Yes, basically, all three materials can be cut with a laser. On polycarbonate, there's a restriction regarding thickness of about 0.5 to 1 millimeter. If you have thicker material, you experience some brown edges. If this is not a problem, then you can go even with thicker materials. If these edges are visible, then you should limit the polycarbonate thickness to 0.5 or 1 millimeter. What we provide is testing and qualification of your materials, which is a good step in the purchasing process of your laser machines, and we provide this for free to make sure that you are satisfied with the process results. There's a general question about thickness of material from David. This depends a lot on the material itself. So for wooden type materials, we achieve something in the order between 10 and 20 millimeters. This is depending a lot on the kind of wood. Wood is a natural material and gives very different results depending on the type of wood. For acrylics, it's up to 20 millimeters. Cardboard works well, corrugated materials works well up to 10 millimeters. Also, this is a good place for pre-qualification to make sure that you get the right solution for your materials.
Okay, I see a question from ink. So from Thomas, how important is the ink in the laser process of cutting, and are some Mimaki inks better than other if we use a laser? So basically, yes, we have different ink types for different applications. Mainly for rigid media, most of the ink, the ink that is used most of the time is the LH100, which is, let's say, a non-flexible ink, but has a very high attachment with the media. So the moment we add flexibility in our inks, let's say that attachment and scratch proofness is going down a little bit. So basically for rigid media with laser cutting with LH100, so the non-flexible ink, that would be the best solution. However, with our LOS 120, which is actually our most popular ink, also that is very good in the resistance of breaking with edges when the laser cutting process starts. However, I would always advise to do a test up front. So that's about the ink. Then it's a little bit about the thickness. So when a question from Guido, no, it was, where is the one? What is the, yes, from Simone, what's the maximum workpiece height thickness for the Mimaki printer? For the 7151, it's 5 centimeters, so that is the max thickness that you can print. In the example that we showed, well, when you talk about cutting, of course, that will depend on your how many watts your laser source will be. I don't know if you can add some comment to that one, Michael.
Yeah, regarding thickness, we have, it depends a lot on the material. The machine itself can run up to 50 millimeters for most machines. We have a few machines that can do thicker pieces. If you have some 3D part that's printed on and you want to cut some small objects out of this, you can go up to 200 millimeters.
Okay, I got a comment. So when you're talking about the height of the objects that can be printed, it depends on the machine, of course. So for our JFX big range of machines, that's 5 centimeters. When you go to the 7151 plus, it is 15 centimeters. So let's say based on the model, also the height of the object you can place on the printer depends.
Mm-hmm. There's one question: are all Trotec machines equipped with a camera, or is it an option? It is an option, and there was the question: is it retrofittable? Yes, it is retrofittable. So if you have a Trotec machine without the camera, it's easy to add one. And then there's a last question from Alex, I think. Is a laser cutter better than a router? Very general question. And the answer is, of course, it depends. It depends a lot on the product portfolio that you are having in mind. We typically see that our customers use both technologies and they complement each other very well, depending on materials, on application types. And if you have both technologies available, both cutting technologies, you're well suited. We have a lot of customers who say, I just want to go with laser cutting, I'm happy with this. But a combined approach is also feasible and gives you the most flexibility in your portfolio.
Okay, I see a question from Silvio. Let me check where that one was. No, it is from Analyze, or they are together in one box, so maybe they are sitting together, I don't know. The question is, with the UGF 3042, we always need to set the media height before printing. So basically, you can set the height of the media manual, so then the machine is not going to measure it itself. The only thing is you need to make very sure that all the products that you are going to print have that same height. The moment you switch, you can use and switch to automatically height detection or change the new height manual.
There's one more question regarding edge quality. How do I make sure that my edges are not brown? Basically, this is a process setting that you're typically combining the right lens with the right nozzle type and the right gas assist pressure to make sure you get optimum edge quality. Burning the ink is not a big issue. We have had many different applications with cutting printed materials, and the ink does not have a detrimental effect on the edge quality. So laser cutting does not destroy the edge in most cases. This is also not a general rule, but our experience is that laser cutting and UV printing work very well together.
Okay, Michael, I think we already answered a lot and we are way over our 45 minutes.
Yeah.
So I would like to suggest that we are going to answer each and every question that was sent by the chat together, or each. Yeah. Yeah, I think then let's end this webinar. Thank you for participating with this webinar together with Mimaki, and I would like to thank everybody that was listening. To join this webinar, keep hold on our website. We are organizing in these times where travel is really limited, a lot of webinars. So thank you once more for listening and joining, and hopefully we can meet later on an exhibition or in our showroom. Thank you.